Today's video covers Lesson 6 in Module 3 for Eureka Math Grade 7, comparing expressions. Hey, looking at question 1, we have 5 times 59 1/3 plus 2/3 minus 2 times 59 1/3 plus 2/3. Now, by way of order of operations, if we're solving this, the first thing we should do is add our like terms, or add in the parentheses, we have some like terms. 59 1/3 plus 2/3 is equivalent to 60. And we have that again over here. Okay. We could go ahead and multiply these. Okay. I'm going to do this two different ways. Over here, okay, well, 5 times 60 is 300, minus 2 times 60, which is 120. When you subtract the two, 300 minus 120, you get an answer of 180. Or you could factor out that 60, because that is a common factor of both of these, and get 60 times 5 minus 2. Well, 60 times 5 minus 2 is 3, and 60 times 3 is 180. Okay. Either one of these ways gets the same answer. It just depends on how you prefer, how you like to think to work it out. Okay. Question number 2. Consider the expression 8 times 2x plus y minus 5 times 2x plus y. Okay, we're going to write the expression with no grouping symbols and the fewest terms. Well, the first thing we need to do is get rid of that subtraction. Rewriting that with an addition expression instead of a subtraction expression. Next, okay, what the parentheses tell us we need to multiply. So I have 8 times 2x, 16x, plus 8 times y, 8y, plus negative 5 times 2x, negative 10x, plus negative 5 times y, negative 5y. At this point, we're going to combine our like terms. 16x plus negative 10x is a positive 6x. 8y plus negative 5y is a positive 3y. Part B wants us to use a different strategy. Well, if you notice, both expressions here have that 2x plus y. So we could factor out 2x plus y and simply take 8 minus 5, which is 3, and then distribute from here. 3 times 2x is 6x, plus 3 times y is 3y. These are the same things here in terms of your answers. Just two different ways to do it. Okay? Whether you're going to factor out that common factor and then distribute, or you're going to distribute and then combine like terms. Either way works just as well as the other. Okay? How does the answer in Part B relate to 2x plus y? Well, 2x and 6x. 6x is 3 times more than 2x. 3y and y. Well, 3y is 3 times much as y. So we could say that the answer, okay, is 3 times the expression 2x plus y. How could we have predicted that? Well, if you are looking at the strategy used in Part B, you would notice that 8 minus 5 gives you 3. And so since we're multiplying 2x plus y times 3, that would give us an amount that is 3 times of what we've got. Number 3, again, we're going to rewrite this because we have subtraction here. So 6 times 2x plus 6. Let me zoom in here a little bit. Plus negative 5 times x plus 3. Okay. Distribute first. So 12x plus 36. Multiply 6 to both terms in the parentheses. Okay. Negative 5, that's my multiplier, my distributor. Negative 5 times x is negative 5x. Plus negative 5 times 3 is negative 15. Combine those like terms. 7x plus different signs. We're going to subtract. It's positive 21. Distribute. So multiply. Then add your like terms. Well, how does the answer relate to x plus 3? Well, if you look at this expression, both terms share a factor of 7. So if we pulled out a 7, well, 7x divided by 7 is just x. 21 divided by 7 is 3. So we could say, it is 7 times, the answer is 7 times more than x plus 3. So 7 times x plus 3. How can we use this structure of this expression to make part A less challenging? Well, if you look at x plus 3, it's right here. Well, how can we get x plus 3 from this? Well, x times 2 and 3 times 2 gives me 2x plus 6. So I could kind of factor a 2 out of here. I could almost make this 6 times 2 times x plus 3 plus negative 5x plus 3. Well, 6 times 2 is 12. Now, I'm not saying everyone has to do this. It's just asking us, how can we make this less challenging? Then we could take the 12 plus negative 5. And we have that 7 times x plus 3, which gives us the 7x plus 21. This is supposed to make this less challenging. I feel like, however, though, just distributing and combining your like terms is probably the easiest way to go about this. Okay. This is just showing you another way to do it. Okay. I feel like this could cause some issues. This way is one way that you can work this out. But we are, factoring twice here to kind of get our answer, whereas we're just distributing, combining like terms, and we've got an answer. Okay. Number 4, Eve orders 7 goodie bags for children in her neighborhood. Each goodie bag contains 6 stickers, 2 pencils, and 3 erasers. Buying a goodie bag costs $2.50 less than buying the items separately. Okay, so Eve is saving $2.50 for each goodie bag she buys instead of just buying 6 stickers, 2 pencils, and 3 erasers 7 different times. Okay. S is going to represent the price of a sticker, P for a pencil, and E represents the price of an eraser. All prices are in dollars. And we're going to write 2 different expressions that could represent the total cost. Well, to begin with, we know that she's buying 6 stickers plus 2 pencils plus 3 erasers. However, if she buys them all in a goodie bag, she's saving, $2.50. Well, this is the cost of 1 goodie bag. If I want 7 goodie bags, I would multiply this times 7. So this is one way that we could write this. Okay, this is the cost. Okay, this is the cost of one goodie bag. Okay, cost of one goodie bag purchased 7 times. Okay. So here's the cost of the goodie bag, but we're buying 7 of them. Well, if I wanted to know what my total cost would be, I could distribute to everything here, which would give me 42S, 14P, 21E, plus a negative 1750. Because when I distribute, okay, I'm multiplying everything here times 7. And since I have no like terms, this would be, okay, the total cost of 7 goodie bags. All right, questions 5 and 6 want us to factor out the expressions. Okay, we talked the other day about we don't want fractions and decimals inside the parentheses if we can help that. Okay, and we don't want if possible negative variable terms. It's going to happen sometimes. But in this case, if I rewrite this, I know that I can think of this as 12, 24, and 36. Well, each of those share a 12 in common. But because it's the 1.2, 2.4, 3.6, I could pull out a 1.2. So if you think about negative 1.2x, negative 2.4y, and 3.6. If you think about it in terms of the boxes, what am I going to pull out? Well, I'm going to pull out a negative 1.2. That turns this into x, because negative 1.2x divided by negative 1.2, now that cancels out the 1.2's. Negative 2.4y divided by negative 1.2 is 2y. 3.6 divided by negative 1.2 is negative 3. Okay, so figure out what they share in common, pull it out, and divide each of these by this number. Then we're going to put parentheses around these, and this is my multiplier, my distributor. So negative 1.2 times x plus 2y plus negative 3. Now, if I'm looking at, okay, I'll make the box over here. I have 2/5 xy, I have 6/5 y, and negative 4/5. Okay. Well, they all have a 5th in common here, right? So we could pull out a 5th. Well, but look at the numerators. They all are even numbers. So I could pull a 2 out of each of the numerators. So if I pull a 5 out of here, 5 divided, that's just 1. All of these become 1s. If I pull the 2 out on top here, okay, now I'm dividing by 2/5. Okay. Well, if you pull a 5th out, you can think of it as there's no more denominators. The denominators are gone. So then it's just dividing your numerator by 2. In this case, I would be left with xy. Well, 6 divided by 2 is 3y. And negative 4 divided by 2 is negative 2. The reason that we're not pulling a y out as well is because not all terms have that y in there. So we put those plus signs between, we move up our distributor, 2/5 times xy plus 3y plus negative 2. Number 7 says the side length of a square is 2/3 g plus 1 centimeters. So we're going to use this to represent the perimeter of the square. Well, how do we find the perimeter of a square? We add up all the sides. Well, if they're all the same side, I have 4 of them. So instead of writing this plus itself 4 different times, I could rewrite repeated addition as multiplication. This represents the side length of a square, and this represents the number of sides of that square. Okay, I have 4 of these because all of the sides are equal, so therefore I am multiplying the side length times 4. Okay, so if I distribute that, 8/3 g plus 4. Okay, so either one of these two would work. Okay, this just represents the 4 sides. This represents the perimeter altogether. For part B, it says one pair of opposite sides of the square is doubled in length. So now we have a rectangle. Okay, so now we only have 2 sides that are this size, and we have 2 more that are double this. Okay, so 2 of those. Okay, so this represents the original side length, and there's 2 sides that are that. I'm doubling the side length, and there are 2 sides that represent that. Okay. Question 8 and 9 are error analysis questions. Jonas says that 10 minus 4 times 2x minus 5y plus 1 and 12x minus 30 plus 6y are equivalent. Okay, we're going to explain why we agree or disagree. Well, if we go through and simplify this expression, 10 plus negative 4 times 2x plus negative 5y plus 1. Okay, we're going to distribute, so negative 4 times 2x, negative 8x, negative 4 times negative 5y is a positive 20y, and negative 4 times 1 is negative 4. At this point, we have only one set of like terms. So we have negative 8x plus 20y plus 6. Now if I'm comparing this to 12x minus 30y plus 6, are these equivalent? No, they're not. Okay. The reason being with that, how could I turn this 2x plus negative 5y plus 1 into this? Well, I think Jonas forgot that you can't combine like terms first, that you have to distribute first before you combine like terms. Okay. So we would say Jonas did not distribute first. He incorrectly added 10 and negative 4. Number 9, Noor states that negative 3x plus 2 plus 4x and 4x minus 3x plus 2 are equivalent. Explain why you agree or disagree. Okay. Well, let's take a look at these. Do they share any factors? I believe they do. They share the 3x plus 2, which is negative because of the minus in front. So what did Nora do here with her expressions? She just reordered them. Okay, these are equivalent. Okay? The expressions are equivalent. By way of the commutative property. Okay. Nor just use the commutative property to rewrite these in a different order. If you solve it out, you will end up with the same response. Okay. She just put the 4x in front instead of at the end.